Today we discuss about a concept called electrical potential difference in electric currents chapter. If you see this water analogy, here the water is flowing from high potential region to low potential region. And if you see, when this container is at greater heights and this container at the lower height, the water easily flow from greater heights to lower heights. This is the natural phenomena we know. It means water always flow from high pressure to low pressure, or high density region to low density region. That is very easy. No need to do any work. But if you want to move the water from low density region to high density region, then what to do? Water can go automatically? No. So then what I have to do? If you see this person going to that height and he pouring the water in the container so that the water flow from greater heights to lower heights. That means the person is doing some work to move to the greater height. In the similar way, if you want to move the charge from one point to the other point, you have to do the work. Let me explain here. This is a conducting wire where you have two ends, end A and end B, and Q is the charge. End A you call VA. VA is called the region having huge amount of charge, and this is called high potential region. So I will write here, this is high potential region, high potential. And if you see this VB is called low potential region. Low potential. So, as the water flow from high pressure to low pressure, greater heights to lower heights, similarly charge Q, or the positive charge, move from high potential region to low potential region. High potential region is where you have huge amount of charge. Low potential region is the region where you have less amount of charge. So charge move from high potential to low potential to make the amount of charge equal at A and B. This is what called equilibrium state. So in these situations, there is no need to do the work. But if you want to move the charge from B to A, from low potential region to high potential region, then charge cannot go automatically. We have to do work. So if you see the third diagram, there is a cell, there is a positive terminal, this is the negative terminal, and the charge Q, which is positive charge Q, wants to move from A to B. Similarly from B to A in conducting wire. So if we move to A to B, the charge Q is not automatically go from point A to point B, because at point B region the long terminal you are seeing, this is called positive terminal. Positive terminal means high amount of charge. So the plus Q wants to move from low amount of region to high amount of region, then it has to perform some work W. So therefore the amount of work done W per unit charge Q is called as potential difference, that is V. So V is called potential difference, which is the amount of work done per unit charge. Right. Now if you want to know the unit, SI unit of V, so if you see this W by Q, W SI unit is joule by Q SI unit is charge, the Q SI unit is coulomb. So see, joule per coulomb, or we can simply say volt. Volt can also be written as V, so small letter V. So the S unit of potential difference V is joule per coulomb or volt. So from this formula you can find the amount of work done or the amount of electrical potential energy, and that is W equal to, if you take the Q which is in denominator to the right hand side, W become Q into V. Therefore W equals to QV. So W equal to QV is called amount of work done, or it is also called electric potential energy, and its unit is joules. So what we understand that electric potential difference is the amount of work done per unit charge, W by Q, and W is the electric potential energy, which is equal to Q into V.